Okay, now we're going to isolate the flooded land. Now I'm going to turn this off because we set the mask, so it cut the layer for us using counties, which is really nice. And for isolating flooded land, the next step is to isolate the area flooded by storm surge of 15 feet. We want to show the area that is 15 feet in elevation and below. In order to make this calculation, we must use a more complex tool than the times tool. So we will be using the raster calculator. The raster calculator allows you to build and execute complex map algebra expression. So on analysis tab back on here, and we will go to tools, and in the geoprocessing pane we will search raster calculator. So there. So raster calculator image, it should be this image analysis tools or spatial analysis tools. So click to this tool and enter expression. So we can open them both and see what are the difference. And we will do this first. Okay, raster calculator. Let's go back. Let's see the image. Oh, that's cool. I think it's the same tool. Elevation. Elevation is smaller and equal to 1/5. There. And then output raster, I will put into Kachina geodatabase. Click open. No, I still have to put a name. Okay, we will say it's flood land. And then click OK, click run, save, and then run. If we just perform a Boolean operation, if the expression is true, that we will change it. So the symbology, and return value is 1, so means flooded, not flooded, that we will change it back. And now we see here, I'm gonna go to symbology, and this one we could say value. This one label, we will say not flooded. Okay, this one is flooded. Flooded. Okay, so the color we will change. This will be green. This one will be blue. There. Okay. And we can zoom in. Okay. I know the symbology is crazy, right? So here, because we perform this Boolean operation, so if this expression is true for a cell, then they return the value is 1. If the expression is false, the return is 0. So in this particular calculation, anything that has a value of 1 fits the established flood criteria of elevation less than or equal to 15 feet above sea level, and thus represents the flooded land. So the image is a little different. We see more flooded area here. Okay, so now we will determine type of land cover. Now we have identified which land is flooded. We must determine the type of land cover for the flooded land, and the land cover used here has been classified from Landsat imagery. So based on the decision classification comparing spectral characteristics or different areas of land, we will turn off land cover. Okay, determine turn on land cover, turn on, alright. So we're going to put land cover on top of everything there. So there. And we will open the attribute table to look at it. Wow. Okay, the attribute table is right here. So that we have the value and everything. We will see 16 classes classification. 16. There, 16. And with a solution of 30 meters. Value represent the classification of land and count is the number of pixels within the raster that have that value. Specifically, we will see that the value of 11, which is water, has a count of 41, 65,853, which is by far the greatest number of pixels. So we could just rank it count and we can say descending, which is 4165,853. Yep. And it's the greatest number of pixel. And that the system separates classification categories in the land cover raster are too specific for the purpose. So we will group similar classifications to reduce the number of categories to 6, which represent distinctly different kinds of land cover. As shown here, we have a table. Reclassify changes the value in raster. So now we will do is reclassify it. So in order to reclassify it, that we have to do is that go to Analysis toolbar in the Geoprocessing pane. That we will say Reclassify tool. And it will be Spatial Analysis. And we will open the Classify tool and use the parameter shown in previous graph. So that input feature, it will be land cover. And value for sure. And then classify. Okay, then I will have to do is start. There. Okay, we will 11 and at oh. So I'm gonna cancel it. Let's open it again. Reclassify. Okay. Input will be land cover value. Start. Okay, start with 11, 11, and then 1. Okay, then 21. Will you move? Okay, next line. 21. There. Oh God. Oh. There, erase everything. Okay. 11. Okay. And then 21. There. 31. 41. 52. 90. 1, 2, 3. Double check. 11, 21, 31, 41, 52, 90. 1, 2, 3. Okay. And then end. So here I'm gonna do is no data. Okay, no data. Okay. And we will have 11 and 24, 31, 43, 43, oh, 43, 43, 82, 90, 95, 95, 127. Okay. 11, 11, 24, 21, 24, 31, 31, 41, 43, 52, 82, 90, 95, 123, and 127, and then no data. No data. Okay, for new, we will have 1, okay, and then 2, and then 3, 3, and then 4, then 5, 6, 0, no D. No D. Okay. So here the classification we did was that use the parameter. So 1 equals to 11 equals 1, 22, 23, 24 you get to 2, okay? And then 31 is 3. 41, 42, 43 is 4. For 5, we have 52, 71, 81, 82 is 5. For 6, it will be 90 to 95. 90, 95 is 6. And 127 is 0. No data is no data. And of course, I just leave the name. Of course, I can do just reland, reclassify land. Okay, and then we will run it. Once it's done, we will close the geoprocessing pan, and we will have now classify all the land in the 3 counties. And then we will isolate land cover with flooded land. So we only want to analyze the land that has been flooded. If you multiply the classified land by the flooded land, every pixel that has a value of 1 flooded land will be retained. And every pixel that has a value of a 0 not flooded will not be shown. Remember that the time spatial analysis tool multiplies the value of 2 rasters on a cell-by-cell basis. In this instance, we will prepare performing a Boolean overlay where all values multiplied by 0 becomes 0 and all values multiplied by 1 retains their original value. So the time spatial analysis tools multiply the value of 2 rasters for cell basis. So we're going to open it up and learn it real quick. We don't need the land cover now. Alright, so now we will learn is the times spatial analysis tools. Okay, there. That's right here. So multiply the value of 2 raster on a cell by cell. So 1 times 0, if you times 0, you get 0. 1 times 1 is 1. 0 times 0, 0. No data remains. No data. 4 times 3, you get 12. 0 times 2, 0. So that's how. Raster 1, raster 1. And 1 times, okay, if you have 2 times 2 times 1 equals 2. 2 times 2 equals 4. So you get a new value. So it's color-coded. Okay. And click Analysis Tools and search for Times Spatial Analysis and use the following parameter. So input raster will be reclassified time. So we combine these two together. So then we go back to Tools. We will say Times again. Times, it should be 3D analysis. Oh, spatial analysis, times. Let's do times, spatial analysis, times spatial analysis for this one. Okay, input constant value, it will be reclassified land. Output, input, the second one, it will be flooded land. And this will be our final, final cover. And click Save. And we will click Run. So we will uncheck and collapse the reclassified land and reclassify this. Okay, we will uncheck it. Okay, I'm gonna uncheck. Okay, and collapse, check flooded land.